Okay, there's a lot of different ways to do this problem. Again, I noticed that on the numerator, I have 1 minus cosine squared theta. If you remember that from Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. And if I subtract cosine squared theta from both sides, I get sine squared theta is equal to 1 minus cosine squared theta. So I can replace 1 over cosine squared theta with sine squared theta. Okay, so I'm going to do that first. So I get sine squared theta in the numerator over tangent squared theta. And then we can use Pythagorean we can use our reciprocal rules. I know that tangent theta is equal to sine theta over cosine theta. So that means that tangent squared theta is equal to sine squared theta over cosine squared theta. So I will replace tangent squared theta with sine squared theta over cosine squared theta. Okay, so I have sine squared theta from the numerator. That doesn't change. And then here, I'm going to have sine squared theta over cosine squared theta. And how do we divide by a fraction? We go ahead and we multiply by the reciprocal. So cosine squared theta over sine squared theta. And you do that to the numerator too. So cosine squared theta over sine squared theta. That's technically over 1. I have cancels. And I see my sine squareds cancel, leaving me with only this cosine squared theta. Another way to write cosine squared theta, this squared on the inside right here is a little bit tricky. This really means cosine of theta, so the ratio of cosine theta, and then you square the ratio afterwards. So these two are equivalent here. All right.